In this video we will see how to create this and this using shaders. As I mentioned in the previous video that shaders are little programs that rest on the GPU. Shaders are very isolated programs that cannot communicate with each other except through inputs and outputs. Now you may ask, what does this mean? When we take a look at GLSL, you will be able to understand it immediately. Now what is GLSL? GLSL is a C-based programming language that is tailored for use with graphics and contains useful features specifically targeted at vectors and matrix manipulation. Now GLSL is written in C language, so there are a lot of similarities in syntax between both. Here are the two basic shader programs. First we declare the version that we are using, then we declare some input and output variables or container. When these shaders are linked into a program, they do not communicate with each other directly and use input variables to receive information and output variable to give information. So if we want to take some data from the vertex shader to fragment shader, we can do this by declaring an output variable or container in vertex shader and an input variable in the fragment shader of the same name. When declaring input variable or container, we first write if we want this container to be input or output, then we write the data type of that container, then the name of that container. The vertex shader must receive some form of input, otherwise it will not work. The vertex shader receives its input straight from the vertex data. To specify how the vertex data is organized, we use the location metadata so we can configure the vertex attributes on the CPU, as we saw with our vertex shader in which the index location was 0. Like any other programming language, GLSL has many data types that we can work with. The most basic data types are integer, float, doubles, unsigned integers, and booleans. It also has two container types that we will be using, which are vectors and matrices. Now in order to show you what I just said with example, we are going to do it practically. So to color each vertex of the triangle differently, we have to pass color data to our shader with the vertex data. Let's write the color data. We are now passing the color data for each vertex, so we have to update our vertex attribute pointer. Notice that we are passing now 1 instead of 0 in the index place. Let's also make our background color black. Here in the shader, as you can see, we are setting an input container with the location metadata set to 1 to receive our color data. And we are also declaring out container to send our color data to fragment shader. Here in the fragment shader, we declare an input variable with the same name to receive our color data from the vertex shader. And with the help of our data, our shader program creates this. Now there is another way to share data with shaders. Uniforms are another way to pass data from our application on the CPU to the shaders on the GPU. Uniforms are global, meaning a uniform variable is unique per shader program object and can be accessed from any shader at any stage in the shader program. And uniform also don't change their values until you reset or update them. To make a container uniform, we just need to add uniform keyword instead of in or out. Here is the example for uniform. First we declare our uniform vector container and then assign the values of that container to our frag color container for processing. Then in our program we find the location of that variable in our shader program with these functions. Then we declare two variables, one for storing time and other for storing the color value that we want to pass to the uniform. Then we manipulate some values to give us color value between 0 and 1. Then we pass the real values to our uniform with the help of this function, which requires the location of our uniform and the other values that are stored in our uniform container. So we pass our values and this is the result. You can also tweak with the values to increase your understanding of these functions.